In this video, we're going to continue to look at protein degradation. And in the last video, we talked about how we can do it with lysozyme. Here is another way we can break down proteins without lysozyme, and that is through our friend ubiquitin. Ubiquitin is a tiny protein, only 76 residues in the monomer, and it's called ubiquitin because it's everywhere and there's a ton of it. This is one of the most highly conserved eukaryotic proteins we have found. In humans, trout, or Drosophila, which are little flies, it's the same thing. This protein hasn't changed, so it's very conserved. And the way that this works is that we will put a bunch of ubiquitins in a chain, all connected to each other, on a protein, and this will mark proteins to be destroyed. Note that they kind of do have to be on a chain. Proteins can get one ubiquitin and that'll change their function, but not necessarily destroy them. Now let's look at the mechanism that we use to ubiquinate something. And it's 3 steps, and we use 3 different enzymes. First, with the C-termini ubiquitin, we use ATP, and we make this thiol ester bond to enzyme 1. Now, enzyme 1, you usually only have one type of enzyme 1 per organism. Once you're on enzyme 1, this will go and transfer the ubiquitin to enzyme 2. You can have multiple different enzyme 2s. So only one type of enzyme 1, but up to and over 20 types of enzyme 2 can be around. And you have different types because they interact with different proteins. Then we have enzyme 3. Enzyme 3 will transfer the ubiquitin from enzyme 2 onto whatever protein you want to ubiquinate. And it's always going to be attached to a lysine residue. And you're going to form what's called an isopeptide bond. And it's called an isopeptide because it looks like a peptide bond. But this N is actually on the side chain of lysine rather than the backbone. And you're going to add more and more ubiquitin, you can get a chain up to 50 ubiquitins long, saying that this protein needs to be destroyed. And in the next video, we're going to look at how this protein is destroyed, and I will see you then.